All right, welcome back everyone. So in this video, we are going to talk about 5.2 infinity series. So if you guys remember in the last session, we talked about sequence, and then we talked about how to define the general form of the sequence whenever you look at the list of the numbers. So there is a arithmetic sequence or geometric sequence. If you remember the difference between them, whether you are keep adding, subtract the number, or you're keep multiplying, dividing by the same number. So depending on those type, you can find out a better general form of the sequence. And also we talk about whether the given sequence is a divergence or convergence. Convergence means that, you're keep listing the number and then they're heading toward a certain number by thinking about the limit concept, so that you can say that it is a convergence sequence. Otherwise, if they are keep going toward infinity or negative infinity, we talk about that as a divergence convergence sequence. So today we're going to do the very similar thing, but now I'm not going to talk about sequence anymore. I'm going to talk about series. Okay, so first thing, I briefly explained what the series in the last session, and then let's define of a series, and then let's talk about whether the given series is a convergence or divergence again. Okay, so it's a very similar topic, but we need to know the difference between sequence and series. So let me take a look at the definition. So we know that if you have whatever the list of the number according to some pattern, we know that the list of those numbers is a sequence, right? And then if you can find out what the general form of the sequence, now you can think about one is arithmetic or geometric. There's two different type of sequence. You keep adding, subtracting a common number to find out the next number. That's an arithmetic sequence. And then if you're multiplying or divide to find out the next number, you keep multiplying the same number or keep divided by the same number. That's a geometric sequence. Now, what I'm going to do, we're going to talk about the series. So series is not equal to sequence. So I'm going to keep using the list of the number. Watch me. If I do A1, A2, I am going to adding all the given list of the number. And then we can condense it. There might be keep going and going forever. Based on your general form, we call this as a summation. The definition of series is the sum of the terms of the sequence. You see the difference? So sequence is the list of the number. You keep finding the next number based on the row, but series, you are adding all the given numbers, right? So that's a difference. Series is a summation of the terms of the sequence. So therefore, mathematically, we are writing S. So you're adding by using the summation notation, and then we can write it as equal to Sn. So again, this is the same rule. So watch me one more time. I have the same list of the number. I'm going to just use the same list of the number, A1, A2, A3. I don't know what the number, but let's say we have some number as a sequence. S1 is you are adding only the first number. Does it make sense? S2 means you are adding first and second number. S3, you are adding up to 3. So therefore, Sn, you are adding all the number up to nth number. So this is a sequence. So that's what I'm saying. If a k is 1, it's going to be only adding 1. K is a 2, second, third. That's the pattern. So same thing, you can think about the summation notation, right? So that's a definition so far. Okay, so we're going to talk about more how to define the series by looking at a couple examples. But the main idea is once you define the sequence, I want to know whether this given series is a convergent or divergent. For example, let's say you have a sequence an equal to 0. No matter what n, first number is going to be 0, second number is going to be 0. They're keep 0, 0, 0. Doesn't matter the position of the number. They're just going to be 0. Series means that we are adding all the terms of the sequence. So you keep adding. The summation is going to be 0. They are going to have the certain number. So it is a convergent. It's not infinity. However, think about it. This is a great example. You have a 1, 1, 1, 1, 1, 1, 1, 1, 1. S1 is going to be 1. S2 is going to be 1 plus 1. S3 is going to be 1 plus 1. Your summation is getting larger and larger and larger. So this is the example where you're going to find out this divergent series. Okay, so let me summarize quickly. Okay, so I'm going to summarize quickly. Series is not equal to sequence, as we know. Example, if an equal to 0, then the list of the numbers of this form sequence will be 0, 0, 0, 0, 0, keep going 0. First one is going to be A1 will be 0, A2 will be 0, right? A3 0, A4 0, always 0. This is a sequence. I'm talking about series. So S1 is going to be A1, which is a 0. S2, A1 plus A2, okay, 0 plus 0, still 0. S3, A1 plus, you are adding 3 number, okay, 0. Therefore, Sn, A1 plus A2 plus A3, da 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 da, A1, you're gonna keep adding 0. It's gonna be 0. So what I'm saying is, I can conclude the series, the SK will be the general form of the series is, or we can say this series converges to 0. That's our conclusion. So from sequence, you can find out the series. They're not the same concept. So then later you can define whether the series is a convergent or divergent. Does it make sense? So I think this example exactly, you can see the difference between series and sequence, and also you can find out the convergent series. One more example, except actually I already show you. Second example, if an equal to 1, what does it mean? This is the sequence. Then when you think of the list of the number, it's going to be 1, 1, 1, 1, 1. So what does it mean? A1 is 1, A2 is 1, A3 is 1, everything is 1. Now I'm thinking about the series, right? S1 will be A1, so 1. S2, A1 plus A2, okay, 1 plus 1 will be 2. S3, you are adding first, second, and third. 1 plus 1 plus 1, gotcha, 3. So if you go to K or N, you can keep on going, A1 plus, A2 plus, A3 up to AK. It's going to be 1 plus 1 plus 1 plus 1 plus 1 plus 1. It's going to be big number anyway, right? They're keep adding, 1, 1, 1, 1, 1. So what is my conclusion? This part, I can use a summation note, n equal to 1. You're keep going infinity. And then I'm adding n, right? The n could be 1, 2, 3, 4. We found out it is going to be infinity. So this case, because the number summation is getting larger, larger, larger. They're not fixed to 0, which is different from the first example. Therefore, the series, in this case, an diverges to positive infinity. So I think this is a great example to see what the concept is between series and sequence, and you can definitely define how to define convergent series and divergent series. We're gonna keep practicing based on this concept. Okay, so I'm gonna hold up here. Does it make sense to you? So I'm gonna give you guys a couple minutes. Think about it, organize it. I will give you like 30 seconds. I'll be back quickly. Okay, are you happy? So if you got that one, you should be fine. Can you show me your thumbs up? I'm gonna keep going, a couple more example based on this concept, I think. Okay, we good? All right, so let's go down slowly and surely. Okay, so this is one of the example I want to think with you guys. So for each of the following series, I will show you more. Use the sequence of partial sums to determine whether the given series converges or diverges. Okay, here we go. All right, we have summation n equal to 1 to the infinity with this general form. So that I just want to know whether it is going to be converges and diverges. This is a summation. So anyway, this is going to be Sn or Sk, doesn't matter. Let's think about it. Let's just find out. This is a series. According to the definition right there. Right? This is the summation, which is a series definition. So it's something going on. So let me elaborate what they're actually talking about. Let's say I want to find out S1. So what does it mean? It means n equal to 1. So that according to this, given information, you can evaluate what the S1. So 1 over n is 1. So 1 over 2 is the first summation, which means just A1, correct? Because I know S1, if I write it, this is A1. Second, right? Summation means A1 plus A2. I don't know here. We have a sequence. We have A1, A2, A3, A4. There, keep going. This is S1. If you're adding this to S2, if you're adding 3, it's going to be S3. So that's what I'm doing. S1 equal to A1. And then I'm plugging in n equal to 1. So this is the first number. And the next one, what happened? S1, we already know that this is A1. I'm going to plugging in this one here, A1. So 1 over plus, but I actually need to calculate first before I'm going to do that. Oopsie, where am I getting? Oh, okay, this one. So we know that information. So let's plugging in n equal to 2. So 2 over 2 plus 1. This is a 2 over 3, right? So let's think about it. S2, instead of writing this, how about that one? S1 plus A2. Are you following? So we already know S1 is this. So you can plugging in here. And then when you look at, this is the AN. So here, AN equal to n over n plus 1. So this is A1, this is A2. So this is A2. So what does it mean? S1 plus A2 is 1 over 2 plus 2 over 3. Just hold up there. I'm gonna hold up here. I don't want to make it too confused. Just one more time. According to the series definition, this is AN spot. So the general form of the sequence is n over n plus 1. If you have a general form, you can find out what the A1, A2, A3, you can find out everything. But we are looking for the series because you are adding all the summation of each term of the sequence. That's the series definition. So S1 is going to be 1 over 1 plus 1 over 2. That's S1. And S2 is S1 plus the second number. So we have a second number as a 2 over 3. So you can have that information. So leave it at one more time, S3. S2 plus A3. Am I correct? We already found out this is S2, correct? So we can plugging in this one, 1/2 plus 2/3 plus, what is A3? You're gonna plugging in here, 3/4. This, if you're adding them, that's gonna be S3. Are we okay? One more time. S4, S3 plus A4. So we already know what the A3, which is these three terms, so 1/2, 2/3, 3/4. What is A4 plugging in 4 here? 4/5. So something we are getting the pattern. We are getting pattern here, so I'm going to minimize it a little bit. Yeah. So I have S1. I have S2. I have S3. I have S4. And then what do you guys think? We are actually looking for Sn. They keep going forever. Sn minus 1 plus An. In other words, this means S1 plus S2 plus S3 plus all the summation up to Sn. They want to know whether this is convergent or divergent. Are you following? So how do I check? It's hard, right? So what we are going to do, we are going to use a squeeze theorem. Okay, so here, let's look at the pattern. This S1, we just know this is S1, so it's equal to 1/2. S2 is this one. This is always less than 1/2 plus 1/2, because 1/2 is a 0.5. 2/3 is a smaller number, 0.3, so that it means 2 times 1/2. I'm just using the squeeze theorem or sandwich theorem. So what I'm saying is S2, we don't know where they're heading to, but this is definitely smaller than 1/+ plus 1/2. Oh, actually my mistake. My mistake, guys, I'm sorry. This is the opposite direction because 2 divided by 3, so let me just calculate it. 2 divided by 3 is 0.66. Actually, they are larger. So I need to switch that inequality. Same thing. 1/2. 2/3 is smaller than 1/2, right? 3/4, sorry, larger. Why I'm keep saying smaller? So 3/4 is a larger. So this is a larger than 3 times 1/2. I'm just making the squeeze theorem. Last one, each term is larger than 0.5, 0.5, 0.5 of the each term. So 4 times 1/2. So therefore, I can make some relationship. So this is 1 times 1/2. S2 is going to be larger than 2 times 1/2. S3 will be larger than 3 times 1/2. S4 is going to be larger than 4 times 1/2. Therefore, I can also make the conclusion Sn is going to be larger than n times 1/2 because of the pattern. Now, I want to know if it is infinity, this is going to be infinity. If it is a convergent, this is a convergent because of the squeeze theorem. So now what I'm going to do to find out whether it is a convergent or divergent, we're going to use this one. I'm going to use the limit. Let's say n is approached to the infinity, and then where actually they are heading to find out whether it is a convergent or divergent. I'm going to bring 1/2 to the front, and then this is going to be n. So what happened? This part is going to be infinity. So 1/2 times infinity, this is infinity. So what's my conclusion? They are actually heading to infinity. Therefore, this summation will be also infinity. The conclusion will be this. We found out divergent. We found out divergent sequence. So therefore, the answer is series Sn diverges to infinity by using the squeeze theorem. So that's how we solve this complicated form of the series. So I'm going to show you entire question. Just think about it. This is how we are actually working on 5.2. So I'm going to hold up here. Does it make sense to you? Okay, take some time. I'm going to show you two more examples like that. Anybody has a question? Are we good? Okay, so this is a series, not a sequence. So think about it. If you guys got this one, how you feel? Maybe you can pause the video and think about it. I just want to see visual thumbs up. Are you guys okay with that? Can we move on? All right, if you don't have a question, I'm gonna go down slowly. One more example. I'm gonna go down slowly. Okay, same question. I wanna know whether this is serious. Oopsie. I wanna know this is serious, is a convergent or divergent. Just you know, this is AN according to the definition. So AN. So if I write it, the list of the AN, if N is a 1, it's a -1. If N is a 2, +1. If N is a 3, so this is the pattern, -1 + 1, -1 + 1, they keep going, right? So this is when N equal to 1, N equal to 2, N equal to 3. I just write a couple partial of the sequence, and then we're gonna know whether this is gonna be sequence or convergence or divergence series. So let's write a couple partial series as well. So S1, right? You're adding the first summation, just -1. It's gonna be -1. S2, right? S1 plus second. So S1 is right there. -1 plus second number is a +1. So minus plus, oopsie, they're going to be 0. S3, it's S2 plus A3. So we already know S2 is a 0, A3 is a -1. So -1, keep going. S4, S3 plus A4, am I correct? And A3, we found out -1 plus A4 is a 1. Oh, we're going back to 0. So what happened when I keep going? Sn will be, right? This is the pattern, -1, 0, -1, 0. So -1, 0, -1, 0. They keep on going. I want to know whether it is a convergent or divergent. But as you see that, we have a two different direction. -1, -1, -1, 0, 0, 0. Definitely this is not the convergent. This is going to be what? Divergent. So therefore, Sn series divergent or divergent series. That's the conclusion, because they are not going to one direction, two different direction, is a divergent. So that's it. That's how you do check whether the series, not sequence, is a convergent divergent. We talked about whether sequence is a divergent or convergent last time, but this is a series convergent or divergent. So I'm gonna hold up here. Are you okay with that? So that's how we are checking, you know, whether it is a convergent, divergent, series. So I'm gonna hold up here. I love to see your thumbs up. Does it make sense to you? Yep, it is. Okay. If you do not have any question, we're gonna keep going to the next example. I'm gonna keep showing you a variety of, you know, AN. So let's take a look at it. Okay, one more. Here we go. I have another AN. So this is a sequence form. So AN, we have what? You're gonna find out the first one. 1/1 times 2. This is gonna, second one is a 2 and 3. Third and 4. 4 and 5. There, keep going. isn't it? So this is when n equal to 1, n equal to 2, n equal to 3, n equal to 4. Keep going. This is a list of the sequence, the numbers. But I'm looking for Sn, right? Series. So let's write down a partial series term. So S1 will be 1 over just first one, right? So 1 over 2, it's going to be 1 over 2. This is S1. S2, you have S1 plus A2. So we have already S1, 1 over 2 plus, and then we know the second one, A2, 2 and 3. So 1 over 2 plus 1 over 6. You can actually adding them up by finding the common denominator. So it's going to be 3 over 6. So 4 over 6, I have a simplified 2 over 3. That's S2. S3, S2 plus A3. So S2 is right here. So 2 over 3 and A3 is this. 1 over 3 and 4. In other words, 2 over 3 plus 1 over 12. Keep adding, finding the common denominator. So 3 will be what? This is going to be, if you multiply 4, 8 over 12. So I have a 9 over 12, simplify 3 over 4. This is S3. S4, one more. S3 plus A4, correct? And then what happened? S3, we already 3 over 4. A4 is 1 over 4 times 5. So 3 over 4 plus 1 over 20. If you summation, I have to get 4 over 5. So this is S4. S1, S2, S3, S4, all the summation of each term. So now I'm going to just minimize a little bit. I want to know Sn. So if I write it, this pattern, the list of the series, the first one is 1 over 2, second, third, there, keep going. And then I can find out the generalized form of this Sn. What is it? 1, 2, 3, 4. The numerator, they'll just keep adding 1, beginning 1, so n. The bottom one is n plus 1. If n is 1, is a 2. If n is a 2, exactly this is the form. So what happened is, here, Sn, the general form is n over n plus 1. That's what you got. This is Sn. So therefore now, you're going to use the limit of that. So to find out whether it is a convergent, divergence, limit n equal to 1, or actually n infinity to infinity, n approach to infinity, n over n plus 1. So do you remember how to find out the limit? The n and n, the degree are equal. So they are going to be coefficient, 1 over 1 is 1. So therefore, the Sn series converges to 1. That's the conclusion. You guys know how to evaluate the limit. So that should be 1 convergent. That's all. So I'm going to show you this example so that you can wrap it up. Okay, so I'm going to give you a moment. Does it make sense to you? Does it make sense to you? Whenever you feel ready, I love to see your thumbs up. Everybody happy with that? Yeah? Yeah. So for the rest of the time, I'm going to show you a different type of infinity series. So I'm going to show you 3 different types of series. One is a harmonic series. So depending on the type of series, you have a concrete answer. It is divergent or convergent. So let's take a look at it. All right. So in harmonic series, the first one is harmonic series. So what is that? So harmonic series, it's very funky. So look at that. This is a definition of the series. And this part is an, right? So we know the first one is a 1 over 1, second number, third number, fourth number, keep going. And then Sn, we are adding summation. So that's why we are adding. adding. This is a series. So now you see the difference AN and SN. So let me write it for you one more time. SN 1/1 plus 1/2 plus 1/3 plus 1/4. We are adding. This is the series. This is a sequence. Okay, be aware the difference AN, SN. Okay, anyway, what is the harmonic series? Exactly, this is the example of the harmonic series. The harmonic series has the form where AN equal to 1/n. So if you have this pattern with the fraction and increasing exactly 1 by 1, 1 plus 1/2 plus 1/3 plus 1/4, always, this type of series will be the divergent. And I will show you why, okay? So the divergent, why? So S1 is gonna be 1, as you see that. And then S1 plus the second number. This is S2 plus the third number. This is S3 plus the fourth number. So you see the pattern. And then at the end, Sn, this is gonna be happening, right? Right? And then I wanna know whether this is a sequence or divergent. So let's check it out. The numerator is the same, 1. So we have, if I just try to find out the generalized form, this is the this is the pattern. This 1/n is the Sn, basically. So here, Sn, the generalized form is 1, because we have, so this is just, 1, and then actually I can add and if 2, 2, 3, so this is our general form, An and Sn. But let's think about it. Let me just get rid of it. Just I want to know. 1/1, 1/2, 1/3, 1/4, 1/n. So let me just think about it. This is actually 1. I just want to know. 1 plus 1/2, it's going to be 1.5. And then as you see that, 1 plus 1.5 plus 1/3, if you look at the decimal, this is going to be 1.5 something 6. So they're getting slowly larger and larger and larger. So as you already see that they're increasing. So the limit and approach to infinity, Sn, this is series, is always infinity because they are getting larger and larger and larger, slowly. So you don't need to actually prove it. Just remember, if you have harmonic series like this format, it's always divergent to the infinity. So that's one rule about harmonic series, okay? So therefore, based on this information, we can take a look at the bottom. Look at that. Okay, this one, they want to prove it. This is a series. Can I bring 5 to the front? So it's going to be 5 times summation from n equal to 1 infinity 1/n. They want to know whether it is a convergent or divergent. Hey, we already know this is harmonic series. This is definitely the definition of a harmonic series, right? Same format. So we know that this is going to be anyway divergent to infinity. So 5 times infinity is still infinity. So it doesn't matter. This is series also divergent. That's how you solve it. Simple. Because we already know what the harmonic series are heading to. It's a divergent. Same thing. Doesn't matter whether you're going to start from 4 or 5. This is a harmonic series. So anyway, it is going to be divergent. Correct? Because this is a harmonic series form. And just want to let you know, I wrote down a little bit of notes about the limit. Many people forgot from calculus 1. So if n is approach to infinity, if you have n, right, this is infinity. But if you have a bottom is a larger, it's going to be 0. -1, it's not, right? One is a positive, one is negative, positive, negative, positive, negative. The limit does not exist. It's not convergent. Anyway, this is a divergence. And then if you have an exponent in the bottom is getting larger and larger. So just 1/infinity is 0. So this is a convergence. So just check it out. You actually learned this concept in Calculus 1. I'm just writing one more note for you. Okay, so that's it. That's the harmonic series so far. I'm gonna just show you two more. That's it. Okay. I'm gonna go down slowly. I think it should be fine. And a couple things about the property. So about series of property. So let's say, this is convergent. This is heading to letter A, capital B. And then you can adding them if it is converges. Separate is also converges. Okay. Subtraction, same thing. You can bring constant to the front. So this is a very regular property that is very similar in limit or integral everywhere. So based on this, concept, let's take a look at it. So the first series is a converges to. Second series is also converges to. And they gave you the first number of each sequence and series. So what is the letter A, B, C? So I can separate it according to the property. So infinity, n equal to A, n plus, n equal to Bn. So we know where they're heading to. 2 plus 1, the answer should be 3. Simple. Second, I can separate it again. So, and then 2, I can bring it to the front. So n equal to 1, an. Actually, this is minus infinity, n equal to 1, bn. 2 times 2 minus 1, still 3. So you can operate them. So last one, you can just think about it. 3 times 2 minus 4 times 1, 6 minus 4 will be 2. So you can operate the series as well if it is a convergence. Okay. All right, so that's the just simple property. I want to just go to the second type of series, geometric series. I'm going to go down slowly. So the second one, first one was a harmonic, and second one is a geometric series. So what is that? So if you remember geometric sequence, you are adding, I'm sorry, not adding, you're multiplying same number. So 3, 9, 27, 81. So this is exactly geometric sequence. You're multiplying 3. And then the general form of the geometric sequence is an equal to a times r to the n minus 1. Same thing for the geometric series. You're going to bring this one here. Oops, you're going to bring this one right there. And then you're adding all the term of the sequence. So this is the series. You're adding. And here is the thing. If the ratio, the common term, this is a common ratio. If the ratio is between negative and 1, always it is going to be series. Converges a series. If the ratio, if you're multiplying such as greater than 3, which is this case, and then or less than negative 1, remember this series will be always divergent. So it's going to be determined by the size of the common ratio. So if common ratio is between negative and 1, it's going to be directly convergence, and then you can find out where they're actually heading to, a over 1 minus r. And then second, if the common ratio is greater than 1 or less than negative 1, it is going to be always divergent. So let's take a look at the example. I will show you. So same question. I want to know whether geometric series is a convergent, divergent. Check this 2 part, the size of the r. So let's look at that. Okay, this is the series. So I know they're keep multiplying some number. Definitely this is A1. So A1 is a 27, right? And then this is the second number, third number, you're adding. So A2 is 18. So 2 from A1 to A2, what happened? You're adding, you're multiplying 2 over 3, 2 over 3, 2 over 3. So we found out that first we can find out the AN. AN is what here? A1 times R to the n minus 1. A1 is a 27. R, this is the R, 2 over 3. So 2 over 3 to the n minus 1. So I'm going to simplify that. If you simplify, actually, I cannot simplify. That's what the Sn. And then now I'm going to convert it to the series. Because the summation, I'm going to plug in here, n equal to 1 infinity. An, we just found out 27, 2 over 3 n minus 1. Basically, I want to know whether this is a convergent or divergent. And what do you need to check? The size of R. These are definitely where? Between -1 and +1. So we know that automatically this is going to be convergent. But where? To where, right? So to find out the number, use this formula. A means A1, 1 minus R. So first number was a 27 over 1 minus 2 over 3. So let's calculate that. I'm going to bring just this number here. So 27 over 1 minus 2 over 3 is 1 over 3. It's 81. So they're heading to 81 as a convergence series. That's how you're checking. Simple. Check it out. This is a geometric series. And then we found that the R is a 2 over 3. You keep multiplying 2 over 3. That's your common ratio. This is a between here. Automatically, this is sequence and this is series is going to be convergent, but I want to know where they're heading to, so that this formula are going to help us. They're heading to 81. If this common ratio was less than -1, or greater than 1, automatically it's a divergence. So this is a characteristic of the geometric sequence and series. Okay, so I want to do just one more example. Can you guys show me your thumbs up? Are you guys okay? So one more example of the geometric series. If you got that one, are you guys happy? I hope this makes sense to ya. Should be. All right, so let me go to down another example of the geometric series. Tell me whether it is a convergent or divergent. So this one. Ooh, what is that? So let's take a look at it. Okay, this is An. So An, I want to find out the first number. Can you? So -3, plugging in 1 plus 1 over 4 to the 1 minus 1. And then second number, -3, 2 plus 1 over 4 to the 2 minus 1. So actually you are able to find out each term. 3 plus 1, 4 to the 3 minus 1. So keep going. I'm going to just simplify a little bit. This one will be -3 to the second over 4 to the 0. So which is a 9 over 1. So just a 9. And then this one, -3 to the third, 4 to the 1. So if you calculate it, it's going to be -27 over 4. This is a second number. Third number, -3 to the 4, 4 to the second. So 3 times 3 times 3, 81, positive 16. So this is the first number, second number, third number. They keep going according to this, pattern. So I'm going to just bring this circle here, right? So they keep going. So what happened is, let me just write down An. So they keep going. So An is 9, -27 over 4, positive 81, 16. So this is the pattern, and we know that this is a geometric. So they keep multiplying some number. How? What is the next? What is the pattern of the R? What is the R? So from 9 to -27 over 4 to get that, the next number, it looks like they're multiplying -3 over 4, isn't it? So 9 times -3, -27 over 4. Same thing from here to get the third number, you are keep multiplying -3 over 4. So we found out the R is going to be -3 over 4. This is between where? -1 and 1. Dun, 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 dun. So we automatically know this is series converges to where? You need to find out that number. According to that, it is a converges plugging into that number. A over 1 minus R. We know the first number, which is a 9. We got the common ratio, -3 over 4. So 9 over double negative change to positive. 1 plus 3 over 4. So 9 over 7 over 4. So you can calculate that. This means 9 divided by 7 over 4. Kentucky Chicken Fried. Keep change, flip over. So 4 over 7. So they're heading to 36 over 7. That's the answer. This is automatically converges because R is between -1 and 1. So that's why I need to find out the coupled partial sequence. Okay, so that's the geometric series. So far, I talk about harmonic series. It's always the divergent series, geometric series. You know, you need to look at the common ratio and compare their size so that depending on that, you can define it as a convergent or divergent. So this is the second, type of series. Now, I'm going to show you the last type of series. Are you ready, ready? So it's going to be just one example. The last one, I'm going to talk about telescoping series. Are you ready? So if you got that one, let's take a look at the bottom example. Okay. So I'm going to talk about telescoping. This is the last one. Let me change the color. So third type is telescoping. So this name is very, very interesting because it is special. So telescoping series is any series where nearly every term cancel what preceding or following term. So you feel like something is canceling. So let's look at this. This is the format of the telescoping series. And then this is very unique because I can separate it. So this is actually same as, this is the telescoping series. So think about it, 1 over n plus 1. You can rewrite it 1 over n minus 1 over n plus 1. They are same. If you calculate it, you're going to multiply n plus 1, multiply n and n. It's going back to 1 over n plus 1. So I'm saying that this an, you can rewrite it 1 over n minus 1 over n plus 1. They're same. And then let's keep checking. Let's find out S1. So S1 means you're going to plug in 1. 1 over 1 minus 1 over 1 plus 1 is a 2. This is S1. Stay there. Let's find out S2. So we already know S1 plus A2. So S1 is 1 over 1, 1 over 2. A2, this is A1. So you're going to plug in just 2. So here, this is your A1, 1 over 2, 1 over 3. Are you okay? So this is S1, this is A2. What happened? Minus 1 over 2 plus 1 over 2 cancel. Okay, let me go the next one. S3. S2 plus A3. So S2 is going to be this 2. So let me write it 1 over 1 before I'm going to cancel. And then A3, you're going to plug in 3 here. 1 over 3, 1 over 4. Then what happened? Come on, guys. Negative 1 over 2, positive 1 over 2, negative 1 over 3, positive 1 over 3 cancel. So what happened is always the middle will be canceled. Only first to last will be remaining. Only first and last will be remaining. This is the pattern of the telescoping. So what if I have Sn? So we know it's going to be A1 plus A2. You're adding all the summation. So it's going to be 1 over 1 minus 1 over 2, S1. And then you keep adding the next one, 1 over 2 minus 1 over 3, 1 over 3 minus 1 over 4, 1 over 4 minus 1 over 5. You keep going. The last one, 1 over n minus 1 over n plus 1. So what happened? Dun, 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 dun. The middle The middle, everything cancel. First, last will be remaining. Now you are going to decide it whether, so Sn is going to be first and the last will be only remaining. I want to know if n is approached to the infinity, whether it is a convergent or divergent. So we know limit, this is going to be limit and approach to infinity, 1 minus n plus 1. So this is going to be just a 1, but this one is going to be 0 because the bottom is heavier. Because this is minus 1 over infinity, correct? So 1 minus 0, this is a 0, is 1. So this is a convergent. So telescoping series will be convergent to 1 in this example. Okay? So that's the characteristic of the telescoping series. Always middle, cancel. Sometimes it's a different pattern, but in general, there's a cancellation going on. Okay? And then in the last, you're just gonna take the limit of the first and last, and then check it out. If n is approached to infinity, where they're heading to. So you can still check whether it is a convergent or divergent. So this is a telescoping series. Are you guys okay? Yes, yes, yes. No, no, no. So can you show me your thumbs up? Are you happy with that? So far, we talked about what? Harmonic series, geometric series, and this is the last types of series. I'm going to do one last example. Ooh, this is the last example. How about that? So I want you guys to check always whether it is a convergent or divergent sequence. All right, sorry, series. So let's look at that. So this is look like some pattern of telescoping, not exactly 1 over n times n plus 1, but you can think about it. I can separate it. This is actually same as we actually begin to, and then ln 1, this part, the inside, 1 plus 1 over 1, you can combine it. So 1 is the same as n over n, right? And then I can add in 1 plus 1. So it means ln n plus 1 over n. I can combine them. I just adding the fraction. Are you okay? And then check it out. You need to see the structure. What is going on? This is ln. Dun, 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 dun. Do you remember the log property? So if I have a log a over b, it's going to be log a minus log b. Dun, 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 dun. So therefore here, you can rewrite it. ln n plus 1 minus ln n. Like a over b, you're going to subtract them each other. So I need the subtraction. You know what? To use the telescoping, you need a subtraction. Because so that you can have some cancellation. So I'm going to, instead of using this one, I'm going to using this one to find out what type of series we have. So I modify the given information into the telescoping form with the subtraction. So now we can do that. I do have S1. You're going to plugging in. The first one, you're going to actually start from 2. So ln 2 plus 1 is a 3. ln 2. This is the first S1. You know what? I don't need to write the parentheses, so that's what it is. S2, we already know that this is S1. And then adding the next one, you're going to plugging in 3. So ln 4, ln 3. So in this time, what do you notice? The first, last is a cancel. Do you see that? And then middle remaining. So let's check one more time. I do have S3. So S2, ln 3, ln 2, plus ln 4 minus ln 3. And the next one, ln 5 minus ln 4. So again, what do you notice? The first, this one, first to last to cancel. And then in here, first to last cancel, something between ln 2, ln 5 remaining. So it's a little bit interesting pattern, but let's keep going. I'm going to keep on going up to Sn. So we know ln 3, ln 2, ln 4, ln 3, We have ln5, ln4, and the last one, what do you guys think? We have ln n plus 1, right, minus ln n. So this is going to be remaining at the end. So now we can think about it. We found out the pattern. ln3 cancel. So ln4. So between here, first and last cancel. Between here, first to last cancel. So between here, first to last cancel. So at the end, you're going to have only negative ln2, ln n plus 2, ln n plus 1. This is going to be remaining. So therefore, Sn, we have negative ln2 plus ln n plus 1. Now what n is getting approached to infinity? I want to know where they're actually heading to. So negative ln2 does not change it because it's like a constant, but then ln infinity plus 1. So infinity is always infinity. So negative ln2, and this is going to be ln infinity, that's going to be infinity. This is entire infinity, correct? So infinity minus whatever small number, it's still infinity. So therefore, the series Sn, we have divergent. Diverges to infinity. That's the conclusion. So this is very unique pattern of the telescoping series. Does it make sense? So likewise, you could try this. The last one. I think I'm just going to write one more space. So here, think about it. You can just keep going. Sn, right? What happened? Keep adding cosine 1 over, because they already have a subtraction. I'm going to just directly find out Sn minus cosine 1 over 2. So this is the first one, adding the second one. 1 over 2 minus cosine 1 over 3. And you're keep adding. Cosine 1 over 3 minus cosine 1 over 4. Oopsie, I need a space. So here, oh, oopsie. So here, we have a cosine 1 over n minus, really, I need a space. And then cosine 1 over n plus 1, isn't it? So look at the pattern. Which one is it canceling? So definitely the middle cancel in this time. And first to last will be remaining. So in this case, Sn cosine 1 minus cosine 1 over n plus 1 remaining. So I want to know n is approached to infinity. What happened? Sn, this is going to be just same cosine 1 and cosine 1 over infinity plus 1. What happened? Cosine 1 is constant, so we don't need to get anything. So cosine 1 minus, this is what happened. The bottom is infinity. So cosine 1 over infinity. So cosine 1, this is going to be 0, cosine 0. So please remember, 1 over infinity is a 0. So this is 1 over infinity plus 1 is the same as 1 over infinity. 1 over infinity is a 0. So basically cosine 1 minus cosine 0, they're going to have some specific number. So this is converges to that number. Conclusion. Okay. So we finish definitely 1.1, 1.2. We talk about sequence, series, especially for the series, we talked about the general sequence, general. We talked about what else? Harmonic series, geometric, and telescoping. You are checking whether they are converges, diverges. You are determined whether the given series convergent or divergent, right? By checking and approach to the infinity, limit concept of the sequence of partial, right, sequence. So that's how you can get, whether it is a convergent or die. Same thing for the sequence and series. Okay, so I show you all the example as many as I can. So you can finish 1.1 and 5.1 and 5.2 quizzes, and we're gonna wrap up today. And then next this Wednesday, we're gonna go to 5.3 divergent test. Okay, so I think we can finish chapter 5 before the final. That's my goal. And then if you have any question, email me and keep engaging with the discussion board so that you guys can help each other if you need. Okay, so I will stop recording at this moment. I will see you guys soon. Thank you, everyone. Bye-bye.